Hello, science explorers! Welcome back to another star-amazing adventure. I'm Teacher Jeanette, and today we're heading straight into the night sky to uncover the mysteries of the stars. We are now in our week 7 to 8 grade 9 science. And our topic for today is very interesting. It's all about constellations, characteristics of stars, and examples of constellations. For our learning competency, we have the following. Show which constellations may be observed at different times of the year using models. So, what are you waiting for? Just sit back, relax, and enjoy the wonders of science. Have you ever wondered where some stars look brighter, some look redder, or some other stars seem to twinkle more? Well, fasten your seatbelts because we're about to blast off and discover what makes each star unique. Have you seen these little sparkling lights in the sky at night? These are stars. Stars are enormous balls of hot, glowing gas. Imagine a giant sphere made of hydrogen and helium, burning non-stop for millions, even billions of years. It is also a type of astronomical object consisting of a luminous spheroid of plasma held together by its own gravity. It will determine the age, distribution, dynamics, composition of the stars in a galaxy, traces the history, evolution of that galaxy. There are approximately 100 to 400 billion stars in our galaxy, and there are about 170 million galaxies. A person can see only about 3,000 stars on average. Now let's talk about its characteristics. Stars' characteristics are size and mass, color, and brightness. Let's discuss first its size and mass. Sun seems bigger than the other stars because it is incredibly close to Earth, only 8 light minutes away, compared to other stars, which is light years distant. Although it seems small in our perspective, but in reality, it is a vast larger than Earth. Its diameter is about 109 times Earth's, and its volume is large enough to fit approximately 1.3 million Earths inside. But compared to other stars like Sirius, Rigel, and Antares, it's incredibly small. Our Sun is a modest star. Comparing it to Sirius, it's about twice its size. To Rigel, which is a blue supergiant, is around 79 times wider, and Antares, which is a red supergiant, is colossal, about 883 times the Sun's width. If it's going to replace the Sun, its radius would extend past Jupiter's orbit. That's really big. High-mass stars burn their fuel incredibly fast and die young in a violent explosions called supernova, while low-mass stars like our Sun burn fuel slowly and can shine for trillions of years before it became a planetary nebula and eventually white dwarf. Next characteristic is the color. The color of the star indicates its surface temperature. Look at the table. It shows the different star with its surface temperature. Our Sun, which is yellow color, has a surface temperature of 5,700 degrees Celsius. Proxima Centauri, which is red, has a surface temperature of 2,300 degrees Celsius. Epsilon Eridani, which is orange, has a surface temperature of 4,600 degrees Celsius. Vega, which is white, has a surface temperature of 9,900 degrees Celsius. Sirius, which is also white, has a surface temperature of 10,000 degrees Celsius. Lastly, Alnilam, which is blue, has a surface temperature of 27,000 degrees Celsius. Based on the table, the color of the star that is coldest is red, while the hottest is blue. Stars slowly change their color as they age. If a cluster still has hot blue stars, it is young. If the hot stars remaining are yellow, like our sun, or red, the cluster is old. As the hotter stars have already died or evolved, they either become extremely hot, small remnants like white dwarfs that slowly cool, or they explode like supernova, briefly reaching temperatures of billions of degrees. Lastly, let's talk about its brightness. Some stars appear brighter than the others, as seen from Earth. This is apparent brightness. It is the star's brightness as seen from Earth. Which star is brighter? Is it Sirius or Rigel? Sirius is about twice as bright as Rigel. Sirius looks very bright when viewed from Earth because it is closer to Earth. When we say absolute brightness, it is the brightness of the star would have if all the stars were the same distance from Earth. Now let's take a look at this picture. Which star is brighter, Sirius or Rigel? Compared to the Sun, Sirius is about 27 times as powerful as the Sun. But Rigel has the power of many thousands of suns. In terms of distance from the Earth, Rigel is almost 100 times farther away than Sirius. Have you seen any pattern of stars at the night sky? Those stars aren't just randomly scattered. People long ago connected them into patterns. These patterns are called constellations. Constellations are imaginary group of stars that form pictures of animals, objects, and people. The name came from early Babylonians and Greek, like the famous Orion the Hunter. In the Philippines, we also have an equivalent name for it. We called it balatik. It represents a hunting trap used by early Filipinos and was used to mark seasons, guide farming activity, and tell cultural stories. The Orion constellation is one of the most recognizable in the night sky. Its main stars include Betelgeuse, a supergiant star forming Orion's shoulder, Rigel, a bright blue-white star forming Orion's foot, and the Tatlong Maria, Nintaka, Alnilam, and Alnitak, three stars forming Orion's belt in a straight line. Why do we see different star patterns throughout the year? It's because of the Earth's rotation that caused the apparent nightly movement of the stars, and revolution, the reason why we see different constellations throughout the year. Stars appear to move due to the Earth's rotations, causing daily east to west motion, and Earth's orbit causing slight shifts, like parallax over months. That's why we can only see Orion the Hunter and Taurus the Bull during cold season, and Scorpius the Scorpion during summer. The 12 famous zodiac signs are also part of the constellations. These are Capricorn, Aquarius, Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, and Pisces. Can you name these constellations? What do you see? It's Virgo, the maiden. How about this one? What do you see? It's Pegasus, the winged horse. Lastly, this one. What do you see? Gemini, the twins. How early people use constellations? First is for navigation. Constellations have been used for centuries to help people find directions. For example, the Big Dipper points to Polaris, North Star, and the brightest star in the constellation, which shows north, since it remains motionless in the sky. Sailors and travelers used constellations to navigate long before compasses were invented. To locate Polaris, face north and locate the Big Dipper. Locate the pointer star, Dubhe and Merak. It will directly point the location of Polaris. Another use of constellations is to tell the location of a star. Astronomers use constellations as reference areas when naming or locating celestial objects, such as galaxies and nebula. For example, Orion Nebula is located in the constellation Orion. They also use constellations as a calendar. Farmers use constellations to know the best time for planting and harvesting crops. The rising of specific constellations help predict seasonal changes important for agriculture. It is also a sign of religion. Constellations are linked to myths, legends, and cultural traditions. These stories help ancient people explain natural events and pass knowledge from one generation to another. To sum it up, stars are massive balls of hot gas that produce their own light and heat. They differ in color, size, brightness, temperature, age, and distance from Earth. A star's color shows how hot it is, and its brightness depends on its size, temperature, and distance. Constellations are a pattern of stars seen from Earth. They help people identify stars, navigate, track seasons, and map the sky. Constellations do not represent real star groupings in space, but are useful reference guides and cultural symbols. Thanks for exploring the universe with me today. Keep observing the night sky. You never know what cosmic wonders you'll find. Don't forget to like, share, and subscribe for more exciting adventures. Until next time, stay curious, stay brilliant, and keep shining like the stars.